Hi, I am Dr. TV Lakshmi. In this video, I would like to explain the working of flash type analog to digital converter. It is also called as parallel comparator analog to digital converter because it is having parallel combination of the comparator. It is called as a parallel comparator, and it is a flash type comparator that is due to the fastest operation. Due to the fastest operation, it is called as flash type analog to digital converter. In this example, that output is in 3 bits. Then it requires the 8 op amps, that is the 3 when the output requires in 3 bits, it requires the 2 power 3, that is the 8 op amps. And to provide the reference voltages for the each op amp, it requires the voltage divider network, which is having 8 equal values of the resistors. Then let us see the voltages at these nodes. At this node, that is at the ground, that is the 0 volts. That 0 volts reference voltage is connected to the this op amp, that is to the negative terminal of the this op amp. From the first resistor node, from first resistor to the ground, that is the reference voltage, that is a 1 by 8 VR is connected to the negative terminal of the this op amp. From the second resistor node, from the second resistor to the ground, that is the 2 by 8 VR, that is the voltage drop across this resistor is 1 by 8 VR, and here 1 by 8 VR. So from the this node to the ground is the 2 by 8 VR is the reference voltage, or that is the voltage connected to the negative terminal. Similarly for the other op amps negative terminals. So by using this voltage divider network, different values of the reference voltages are connected to the negative terminals of the all these comparator, and Vin is connected commonly to the all the non-inverting terminals of the these op amps, and these outputs are connected to the inputs of the 8 line to 3 line priority encoder. Based on these inputs, it gives that binary output. Let us see these examples, that is Vin equal to 0 to VR by 8, that is Vin equal to greater than 0 and less than VR by 8. So the voltage at this node is the 0 volts, that is the reference voltage, and Vin is the greater than 0. So the non-inverting terminal voltage is greater than the voltage at the negative terminal of this op amp is op amp. So that output is the plus reset, that is the input of the this 8 line to 3 line priority encoder is the logic 1. Here this input is, we are assuming, less than VR by 8. So that remaining op amps non-inverting terminal voltages are less than the voltage at the reference voltages. So that corresponding outputs are zeros. So this priority encoder, this X0 is 1, that remaining inputs are the zeros. So that output is a 0 0 0. For example, if you take the, to understand easily, if we take the example that VR equal to 8 volts, then this voltage at the this node is the ground is the obviously it is the 0 volts, and it is the 1 by 8 VR, that is when VR is the 8 volts, that is the 1 volt, and it is the when VR is 8 by 8, that is the into 2, it is the 2 volts, and it is the 3 volts, it is the 4 volts, this is 5 6 volts, 7 volts, and it is the 8 volts. We are assuming that VR equal to 8 volts. Suppose when Vin equal to 0 to VR by 8, that is, for example, it is a 0 to VR by 8 means that is a 0 to 1. Let us assume that value is the 0.5 volts. Suppose it is the 0.5 volts, that is 0 to 1. So negative terminal is at the 0, and input voltage, that is the 0.5 volts. It is the, if it is 0.5 volts, then this voltage is greater than the voltage at the negative terminal, so it is the 1. Here it is the, this voltage is a 0.5 volts, and voltage at the negative terminal is a 1 volt. So negative terminal voltage is greater than the voltage at the positive terminal. So that x1, that is the output of this comparator, is the minus V set or logic 0. Similarly, that other op amps, voltage at the positive terminals is less than the voltage at the negative terminals. This is the 0.5 volts in this case, this example, and the voltage at the negative terminal is the 2 volts. So negative terminal voltage is greater than the voltage at the positive terminal. It is also minus V set. Similarly, the outputs of the remaining op amps are zeros. And when it is the 1 0, that is the x naught is the 1, that remaining inputs are zeros, that is the least priority, that is the that output is the 0 0 0. For example, that Vn is greater than Vr, 1 by 8 Vr, 2, and less than 2 by 8 Vr. As we discussed that Vn equal to, we are assume that is the 1.5 volts, and this when it is the 8 volts, that is here this voltage is the 1.5 volts and it is the 0 volts, 0 to, so voltage at the positive terminal is greater than the voltage at the negative terminal. So it is the 1, it is the 1.5 volts, and we are assuming it is the 1 volt. So voltage at the positive terminal is greater than for this op amp. So that output is the plus V set or logic 1, and it is the 1.5, and we are assuming it is the 2 volts. Then this voltage at the positive terminal is less than the voltage at the negative terminal. So that output is the minus V set or logic 0. Similarly, for these remaining op amps also, outputs are logic 0. Then this priority encoder inputs are 1 1 0 1 1 0 0 0 0 0 0. That is the x naught is 0, x1 is 1. The remaining outputs of these op amps are logic 0. So that priority encoder output gives us a 0 0 1. Next example, Vn equal to 2 by 8 Vr to 3 by 8 Vr, that is the greater than 2 by 8 Vr. So up to this op amp, the voltage at the positive terminals is greater than the voltage at the negative terminal. So that outputs of the op amps are plus V set or logic 1, 1 1 1, and the remaining op amps voltage at the positive terminal is less than the voltage at the negative terminal, because that output is less than 3 by 8 Vr. So these outputs are zeros. The outputs of the op amps are inputs of the 8 line to 3 line priority encoder. Inputs are zeros. So that this outputs of the priority encoder is the 0 1 0. Next example, 3 by 8. Suppose that Vn equal to 3 by 8 Vr to 4 by 8 Vr. That is the greater than 3 by 8 Vr and less than 4 by 8 Vr. To take the numerical example, that is, we can assume that is the 3.5 volts, that is the greater than 3 and less than 4 volts, when we assume that we are equal to 8 volts. Here this reference voltage is the 3 for this op amp, and for this op amp that reference voltage is the 4 volts and the input voltage is the 3.5. So up to this op amp, this input voltage or voltage at the positive terminal is greater than the voltage at the negative terminal. So these outputs of op amps outputs are plus V set or logic 1, and the inputs of this priority encoder as the 0 0 0 0. These zeros, op amps outputs are zeros or priority encoder inputs are the 0 0 0 0, and the remaining op amps outputs are ones. So that priority encoder output gives us a 0 1 1. Similarly, for the next example, Vn equal to 4 by 8 Vr to 5 by 8 Vr. Then we get the this up to this op amp that outputs are logic 1 and the remaining are the zeros. So we get the 101. For the next example, that is 6 by 8 VR to 7 by 8 VR, then we get the 110 output at the priority encoder. And when the input is the 7 by 8 VR to VR, that is the input is greater than 7 by 8 VR. So the voltage at the non-inverting terminal or positive terminal of the all the op amps is greater than the voltage at the negative terminals of the each op amp or comparator. So that outputs are the logic ones. So that 8 line to 3 line priority encoder gives the, that is the 111. That is the working of the this flash type A to D converter or parallel comparator A to D converter. The advantage of this comparator is it is the fastest A to D converter, because it is having the op amps and voltage divider network and this priority encoder. When the input is given to this terminal, then itself it gives the, that parallelly it operates all the op amps and these resistors and this 8 line to 3 line priority encoder. So the delay is very less. It may be get, that is the less than the 20 nanoseconds also. So that is the advantage of the main advantage of the this comparator, this A to D converter. That's why it is called as flash type A to D converter. And drawback or limitation of this flash type A to D converter is the, it requires the, when number of bits are increased, it has to increase the 2 power n op amps. That is the, it is by increasing the 1 bit, each bit it increases the number of op amps into doubles the, that required op amps are the double. That is the main drawback of the this flash type A to D converter or parallel comparator A to D converter. Thank you for watching.